Hi everyone, my name is Antonio Leiva from antonioleiva.com, and today I'm coming with a very important topic that I really wanted to explain because I think you will need it sooner or later if you are right now working with Java and you want to start using Kotlin in your projects. Imagine that you have been developing a project for some time, let's say in your current company or a side project where you have been using Java for long and you have a big base code that is using Java. Of course, now you want to start using this shiny new language that is Kotlin, and you are really interested because now you know that Android is Kotlin first, so you need Kotlin to continue developing Android apps in the future. But you have the problem of this huge code base that is written in Java. There's no problem at all because, as you may know, Kotlin is 100% interoperable with Java, and this means that you can use all the code that you write in Java from Kotlin, and you can use most of the code that you write in Kotlin from Java. And I say most because we'll see later a few features that you are not going to be able to use them exactly as they are written. But that's what I want to cover today. I want you to clear your questions about all this. So let's get started with a very simple example. So we are here in our main activity, which is written in Java. This is our huge base code. In my case, it's only going to be a project that I just created because we don't need much more boilerplate to understand it. But we now want to start writing a Kotlin code in our Android app, which was originally written in Java. So the first thing I'm going to do is to configure this project to be able to start using Kotlin code inside of it. So the only thing you need to do is to go to Tools, Kotlin, and configure Kotlin in project. Android with Gradle in our case, because it's an Android module, and we can choose all modules or a single module. In our case, we only have one module using Kotlin, so let's go for it. This is changing a few things that I have explained a lot of times in very different places, so I'm not covering them today. But now we have our project configured, the Gradle files have been configured to be able to start using Kotlin in our project. For instance, you see here the plugins that we are going to use to create our Kotlin apps or Android apps using Kotlin. So now that we have this, I'm moving to the project view, which is easier to me to understand. We want to start writing a Kotlin code, right? So we are going to create a new activity that will be in Kotlin, so that we have a couple of classes to check how the code from one can be used from the other and the other way around. So here we choose empty activity. I'm calling it detail activity, and the source language will be Kotlin. Perfect. So the first part I want to cover, because it's shorter, is how can we use the Kotlin written in Java from Kotlin. And this is really easy to understand, but will be the most typical one, because every time we create an Android app using Kotlin, we are forced to use Java code, because we are using, for instance, the Android framework, which is completely written in Java, or the Android support libraries, which is mostly the same. So we need Java code in our Kotlin code always. And what are the things that we need to take into account? The first one, and I think probably the most complex one, is the nullability. As you may know, Kotlin has nullable and non-nullable types, but Java doesn't. So the integration of the types from Java to Kotlin is a bit tricky sometimes. We can have three different situations. The first one is that we are using an object that we know that is nullable when coming from Java. I'll explain now in a minute how we can know that. So the object in Kotlin will be always nullable. We are forced to check nullability. We can have the opposite, that the Java code is written in a way that lets Kotlin know that the object never can be null, so we can use it as non-nullable all the time, and we don't have the option to use nullable in that object. And the third one, which is less and less common, but it's still pretty common, is that when we are using a Java library, we don't know whether a type is nullable or not, and the compiler will let us decide. This is the most tricky option and the one I want to talk more about, but let's start, for instance, with the first one. Here, if you see in the detail activity, we are overriding on create. This is the typical thing in an activity, and we are getting here a bundle of nullable type. So if we want to use it, we will need to do save instance state, and if I try to do dot I don't know, put boolean, you'll see that I get an error here. This is because the type is nullable, and even if this code is coming from Java, I'm forced to check the nullability. If I do this, for instance, I could call that method. But what happens if I try to remove the question mark from here? It won't let me. It will say that I'm not overriding a class in the Java code. So this is efficiently becoming sure that this type is nullable. And why is this? If we go to the implementation in Java, we'll see here that this argument is marked with the nullable annotation. So when the code in Java is properly annotated with the nullable and non-null annotations, Kotlin is able to know the right type for this object and will do it for us. We cannot change that option in any ways. So here, as the same instance state is marked as nullable, we need to try to deal with it as a nullable object. On the other hand, there could be that this library is not properly annotated, in our case the Android framework, and Kotlin cannot decide for us whether something can be nullable or not. We have here an example, for instance, on create options menu. If we see, we get a question mark here too, but let's see what happens if I remove it. It doesn't happen anything, it keeps compiling, as opposed to the previous example that we saw before. Why is that? If we go again to the implementation, we'll see that this method is not annotated in the Android framework. So the Kotlin is not able to infer the type for us. When this happens, what Kotlin let us is to decide for us whether we want to deal with it as a nullable or as non-null type. In our case, we need to be very cautious here, because if we don't know for sure what the Android framework is doing, we should be always checking for the nullability, just to make extra sure that we are not running into any null pointer exception that we could not know about. Because imagine that I do this, I remove the question mark and I do menu dot add or whatever. If I do this and this type and this object is null because the Java code is sending us this object as a null, it will launch a null pointer exception. So if we are not sure how the framework is working or the library that we are using is working, and the documentation about that library or framework doesn't tell us what it's doing exactly, it's better to keep the nullability and use the save call operator or an if expression or whatever that make us sure that this is working as expected. In this particular case, I know that the Android framework is not sending a nullable menu here, and I could remove it, but this is because I have checked the code and I'm sure that this cannot happen. But if you are not sure, it's better to keep the nullability. I also should say that the Android team is working hard to add all possible nullability annotations to the framework code. So in the future versions of Android, there will be less and less situation where we don't know whether something can be null or not. So as now Kotlin is so important in Android development, they are putting a lot of effort in reducing the number of places where this happens. And I'm sure that in API 19 and the next, 29 and the next ones, it will be much easier to detect all that. So what else we have in Java, in Kotlin, when we are using Java code? The second thing is that we have some simplifications of our code to make it more similar to the Kotlin code. For instance, if you have some knowledge about Kotlin, otherwise I'm leaving you a link here below to a free training if you want to start now with today with learning Kotlin. But if you have learned a little about it, you will know already that instead of having fields in Kotlin, what we have are properties. Properties are like fields plus a getter plus a setter from Java. So what Kotlin is doing here with the getters and setters that come from Java is mapping them automatically to properties in Kotlin. So if we have a getter, we would have an immutable property from Kotlin, and if we have a getter and a setter, it will be mapped to a mutable property in Kotlin. For instance, if we access to support action bar, which in our case we'll see that if we want to change something, for instance called get text, get title is title what I wanted to look for, set title, whatever. The first thing that we can see here is what we talked about before, as this is a nullable variable in the support activity, and we are not checking nullability, is showing an error. And if we go to the implementation, we'll see that the get support action bar is marked as nullable. So here we are seeing what I wanted to explain. This in fact would be get support action bar, get title. Well, this would be nullable. Get support action bar, set title. If you see, this is showing us warnings because, as I mentioned, Kotlin is mapping these two properties, so we could use it as support action bar instead of get support action bar. So we could transform this code into something like support action bar title equals whatever. And as you see, this code looks much more like Kotlin because in Kotlin we rarely use a method that is called get or set, because for that we already have the properties, and this is much easier to read and understand that all this get, set and all that. The code becomes much cleaner. The second thing we have, that if you are using Java 8 you will already be used to it, is that when we have an interface with just one method in Java, it's automatically mapped to a lambda in Kotlin. For instance, if I wanted to do here, imagine that in this activity detail I have a text view, I don't care much about this. I just want to give it an ID so that I can use it from the detail activity. I'm not going to worry now about this making it look good. So here with Kotlin Android extensions I could access to message directly, and let's say that I want to put a set on click listener. The regular way that we would do this if we want to mimic the code in Java 7 would be an object that implements view on click listener, and then I implement the method on click, and here I can do whatever, print x. I don't care about this. So as this on click listener is an interface with just one method, I can use this as a lambda, and the code can be much simpler than what we are doing right now. If you see here, even the IDE is already recommending us to do this, so we could use the IDE to help us and do Alt Enter and convert to lambda, and this is the code we get when simplified. So these are the things that we need to know when using Java code from Kotlin. The rest works without any issues. It works in a very simple way, and it's really easy to use Java from Kotlin. In fact, if you are using the Android framework and you are used to write Kotlin code right now, you probably forgot that the Android framework is written in Java because you won't have any issues in your day-to-day work. But what happens when we do it the other way around? When we want to use Kotlin code from Java code, because if you have an old project that is using that has a big Java code base, it's very possible, in fact it will be almost sure, that you will need to use Kotlin code from Java code. And to do this, I'm going to cover the most typical things. In fact, if we have a regular class, let's say Kotlin class that is called my provider, whatever. This is a class, and it has a property that is called val p type string my provider, whatever, this doesn't matter. If I go to the main activity and try to create a new instance of this provider, I can do my provider equals new my provider, and I will be able to access without any issues to provider.getP. If you see, I can use it perfectly from Java, and in fact this is going to do the backwards compatibility. If you have the same we had that when we use Kotlin Java code from Kotlin, the getters and setters are mapped to properties, it also happens the other way around. When I'm using Kotlin code from Java, the properties are mapped to getters and setters. So it's really easy to use, and the Java code will keep looking like Java, the same way as the Kotlin code will remain much in a Kotlin way. But things become a little more complicated when we start using some of the features of the Kotlin language that are not in Java. For instance, I'm creating a file called test, and I'm creating a first level function so that we can see how it works from Java. So creating, for instance, here a function called logd that receives a message, and that's log.d with an empty tag. Sorry, this would be a message of type string and message. So let's see how this works from Java. From Kotlin I could do log d here, hello world, but if I try to do the same from Java, log d hello world, it won't work. But as you see here, it's trying to recommend us something that I could include statically, but let's see how it's called exactly. What we have right here is a class that it has created for Java that is called test.kt, the same as the file but removing the dot and upcasing the k, test.kt logd. And this way we can call first level functions from Java without any issues. The only thing that we need to remember is that we have to prepend the name of the class. What happens in the case of extension functions, for instance? Imagine that we have an extension function like this. An extension function over context that is a toast that shows a message of type string again. And we have toast make test, this message toast length short dot show. From Kotlin, as you may already know, I can call it like a regular function from the context. Hello, this would be the same as this dot toast. This behaves as a regular function for the context, but in main activity we don't have that option. So let's use test.kt again as a bridge from Kotlin to Java, and let's see what happens. We can call toast the same that we were doing before, but in the case of Java we need to pass the receiver as a first argument, and we have the second argument here like the one that we had before. So we will need to do test.kt toast this message hello. If you think about this would be exactly the same that we would do in Java if we were creating an utils class, an utility class, where at the end we don't have other way rather than passing the receiver as the first argument. If you have created a utility function before related to a toast, you probably did that, passing the context as the first argument and the message as the second one. But let's imagine that we don't like much this number or this name for the class because it's not very useful and it's a little bit cryptic. So what we can do from this file is to change the name of the class that is going to build, to auto-generate. To do this, we would use this annotation, file jva name, and here we write the name of the class that we want to give it to this file. For instance, let's say utils, because we usually call utils when we create this type of utility classes from Kotlin. From Java, we can do the same with Kotlin. And if we get back to the main activity, we would be able to do utils logd and utils toast. So as you see, you can configure this name as you want to fit the style of your code. The next one would be how the default values for the functions work. Imagine that we have a default value for this argument for the length of the toast, which is an integer, and instead of calling here text long, we say length. In Kotlin we have the option to provide a default value for this length. So in case we don't provide any length, it will use the one that we define here. For instance, toast length short or length long. Let's say less short. So now from the detail activity we can call this toast hello or also specify the length. We have the two overloads implemented in the same place. If we get back to the Java code, we'll see that this no longer works, is no longer compiling because it's always asking us for the third argument. We would need to do here test toast length long. But we may want to use the other overload. To do that, what we can do here in the definition of the function is to use the annotation called JVM overloads. With this, it will create all the possible overloads in the Java bytecode, in the bytecode of the app, so that from Java we can use all these overloads without having to rewrite anything or to fill in the arguments that we don't want. We want to use the default ones for this. So if we get back now to the main activity, we'll see that this now is compiling, but we have the two options, the one with the length and the one without it. So this is extremely helpful when we are writing Kotlin code and using it from Java. Another one would be the lambdas. Let's say that we have in this provider a function that is called doAsync, and we have a callback here that returns a boolean if everything went okay, or if everything went okay it will return a true and otherwise a false. So let's say that this does whatever and then calls the callback to inform with true, let's say. How can we use this doAsync from Java? Because this is a lambda and lambdas don't exist in Java. Let's say what happens. Getting back to the main activity, if we do we have here the provider already, provider.doAsync, we see that this is receiving an argument that is of type function1 and with some generic types that are specified to this particular case, like boolean or returning unit. So as you may see, from Java we are converting this lambda to an object, an interface with a function, that the function you will see that is called invoke, and we can keep using it. We can do async, and we can create here an object that is new function of the correct type, boolean unit, the input argument and the output argument, and here the invoke function. Here we could do whatever we need. Print system out, print, whatever. This is much more boilerplate than when using it from Kotlin, but we can still use it, and you see that is mapping the lambda to a function with the same arguments. We can do this much simpler if we use the Java 8 integration. We can do here to function project structure, the app module, and choose the source compatibility to 1.8. This will enable some of the features of Java 8 to the Android code, and when this compiles, we'll see that it is allowing to make this function a little simpler. As you see, this appears as gray because it can be converted to a lambda. In Java 8 there are lambdas are a little different in structure than the lambdas in Kotlin, but it will allow us to simplify the code a little more. What else? Now that we know how to use lambdas, let's see how properties work as getters and setters. We already saw the getter here, but imagine that we do this bar. We can also use the setter here, provider set p, and set whatever we want here, my new value. So as we mentioned, the properties are mapped to getters and setters in Java. Not going to stop here more because I explained it before. But let's see what happens with objects. For instance, if I create a new Kotlin object, for instance, my database, function save object, let's create here class called data that receives x a name string and arg string, whatever. I just want a class to put it here and say that data. And here it doesn't matter what we do. What I want to show you is how to use this object. From Kotlin, what we would do is my database dot save object, new data, sorry, with the new, without the new. In Kotlin we don't use the new word, whatever and whatever. And if we want to use it from Java, we will need to use my database instance. If you remember, an object in Kotlin is like a safe singleton in Java, so we can access to the instance with this property. Instance says object new data, whatever. So again, we have a very easy way to use objects from Java code. So imagine that we don't want to use this instance from Java because this is not very Java code. If we have an object with an static function that we want to use from the outside without calling a specific instance, as this function right now is not using anything from the object, what we can do is to use a JVM static function. This will say the compiler that this function is static so that we can access to it without using the class that is wrapping it, in our case the object. So now, as you see here, is showing a warning because we can access directly to the static function and we can avoid writing the instance word. Again, this is only if the function is not using the state of the object, because otherwise it probably won't compile. And the same we are doing here with the functions, we can do it with the properties. We can go here to the provider, to the database. Let's say we have here db of type any, whatever. Not a function, but a property, val_db. I'm going to say it's string so that it compiles. If we don't want to access from the main activity the same way as before, we will need to do my database instance getDB. What we can do is to use the JVM static 2, and we can access without it. Imagine that apart from this, we don't want access as a getter because this is an element that is not going to change. So using a getter for this is only making things more difficult to understand. So what we can use here is another annotation that is called JVM field. I can probably use both at the same time. That, as you see, I can now access this way without having to use the getter. I could save this to a string x equals my database. So if you are not going to use to modify that field and want to provide it as if it was a public field in Java, you just only need to use the JVM field annotation, and this will work automatically. With data classes, we had other things. For instance, let's modify this class data to a data class. These now need to be properties, otherwise the data class cannot be instanced. So now that we have this, of course, if we use it from Kotlin, we can create a data variable, and here I can do different things. Some things that are very specific to the data class are the toString that will return a readable string. We have a copy method that will return an implementation of this object by changing only what we want. For instance, I only want to change the arcs here, so I could do it like this, and I could also use the destructuring to save the name and the arcs in a couple of variables when they are assigned to this data class. So how all this works from Java? If I go to Java, as you can see, I can also create an object, but some things are different. For instance, if we do data to string, we'll keep getting the cleaner to string that we saw in the Kotlin data classes. The same for equals. We can use equals, and it will keep comparing with the properties instead of just using the default equals, which only compares the object value. So these two things are even useful when we are using data classes written in Kotlin from Java. But there are things that obviously we cannot use. For instance, the data.copy, as it's using the named arguments which don't exist in Java, we cannot do much. The only thing that this copy allows is to create a copy but passing all the arguments, so it is the same as using the regular constructor. It doesn't provide anything extra, and of course the destructuring also doesn't exist because we don't have a way to represent that in Java. So still data classes have a lot of value in Java because we don't need to create the toString and the equals, but there are some things that obviously cannot be mapped to Java from Kotlin. Then we would have the shield classes. Imagine that I have a shield class that is like this. I'm going to create it here, for instance, shield class. I'm calling it, I don't know, filter, or for instance, filter class by type, which has a type that is called string and extends from the shield class filter, and an object called none, which also stands for filter. This would be a filter that can filter by type or do no filters at all. If I use this, imagine that we are using a when val result equals when, well, I'm creating a function that receives a filter receives a filter, and here I want to save a result, whatever it is, that when filter, if I use the exhaustive when here, when I create the remaining branches, which are the limited options that we have in the sealed class, the when expression is able to know that we are covering all cases, and it doesn't require us to write an else. In fact, here it will show a warning saying that as the when is exhaustive, this else is redundant. So the compiler is aware at every moment what are the number of subclasses of this filter class. But if we go to the main activity and try to do the same, we create a function, private void filter. The first thing that we cannot do is to use this filter on a switch, because this is Java, and Java switches are not as powerful as when. So what we can keep doing is to use the filters as as regular classes. For instance of by type, filter.bytype. I can, of course, do the casting. This in Kotlin would be automatic, but here in Java we have to do it automatically by filter.cast by type, something like this. By type, and this is like this. So we can do this and then access to the properties by type.getType, but the compiler is not helping with this in any way. So the class still exists and we can use it, but we don't get any benefit from Java when using a sealed class as opposed to using a regular class. What else we have? For instance, if you remember that we can have inline functions. For instance, let's say that I have another inline function that is a toast. I'm calling it toast2 so that we have it easier to use it. And instead of getting the message as a string, it is going to use a lambda that receives a string and returns unit. So here we would do the same as above. So instead of using the message just like this, I'm using here those length short. Just like this, we would do the call to the function. In fact, it's the other way around. It receives nothing and returns a string. That is what we need from this function to show a toast. Remember that from Kotlin, if we use it without inline and we go to the main activity and call it, I'm going to remove, the detail activity, I'm going to remove all this so that we can see better in the bytecode what is happening. Removing on create options menu too, these two, and I'm doing here toast 2 and hello. If we see the bytecode of this, we will find here that what this is doing is calling the function toast and creating a function to implement the lambda that we were passing to the function. But if we use inline here, instead of using a regular function, we make it inline. Inline, what it does is substitute the call to the function with the with the code inside the function. I have another video related to this, so you can check my YouTube channel, or I leave it here below too in the comments, in the description section. So what I'm doing here is I change it with inline. Getting back to the main activity, if we check the compiled code, we see here that as it's substituting the call to the function with the code inside the function, it doesn't need a lambda anymore to represent an object anymore to represent the lambda, and we can do this code much more efficient than what we had before. So if we use this from the main activity, we can still keep using it. Those two, this, and here we need to create a function to represent the lambda. So in the case of Java, the inline doesn't do anything. We still have to create the object to represent the lambda, and this way it can use the function but not do the, I could say here string. I can use the function, but it won't do the efficient solution that we saw when using inline from Kotlin. If you still don't believe it because you are seeing a lambda here, what I did just to check it is to decompile the code that this APK generates, and I saw that it was creating an object, so it's not able to apply the inline substitution, and as that it needs to create the object anyway. And to end with this, I'm covering another example that I also did in the video I mentioned before, the one about inline. There I also explained reified types. I really recommend you to subscribe to this channel if you don't want to miss anything, because I'm covering a lot of concepts and some of them are interrelated, and as I mentioned, I've talked about it before in this channel. So just as suggestion, please join to the channel here below and you won't miss any of the new videos. And if you want to be extra sure that you receive it, you can click on the bell so that you get notification when I launch a new video. Said that, what I did in that video was to create an inline function called start activity that was applied to context, which used a reified type, reified t, that extends activity. I'm not covering the explanation here because I explained it in the other video. And here I could do start activity with a new intent that receives this and the class Java. So if we try to use this function from the main activity and do start activity 2 from the utils file, you will see something interesting here. It recognizes the function as an existing function, but it's mentioning here that it has private access. So from Java side, the inline functions are perceived as private functions and we cannot access to them. So this is one of the very few cases where the code that we write in Kotlin cannot be used from Java. We could create a wrapper or something like that for Java specifically, but the reified types in particular cannot be used from Kotlin, and this is from Java, sorry. And this is the only thing that is not covered and that you won't be able to use from Java. So this is all I wanted to cover in this video. I hope it helps you in the case that you are started using Kotlin code in a Java project, and that it makes it really easy to start using it, because Kotlin is a very powerful language, and as you can see, even using Kotlin in a Java code is giving up is giving us some of the advantages of the language, and we can simplify our Java code using Kotlin code in our projects. So I really encourage you to start using Kotlin in your projects, and if you have any questions or any ideas for new videos, please let them here below in the comments, and I'll take note for future videos. Thanks again, and see you in the next video. Bye!